All right. Hello. And back to another IncusOS related live stream. Uh, f- just kind of, usual kind of recap of kind of where we're at. With last week's changes, Incus, the management daemon is an actual daemon now. It's run automatically on first boot, well, on every boot of an IncusOS system. And then we updated all of the scripts and tooling and stuff uh, to deal with that correctly. So that's basically what happened last week. I can just go look at the kind of set of commits that happened since, and then take things further with even more kind of initial provisioning, type integration, which is what's next on the list for IncusOS. So down here we can see what kind of landed last week. So that was the work to turn IncusOS into an actual daemon. That was the main change that did that. And then a number of follow-up tweaks and changes to update everything to handle that correctly. And following that and some more tweaks on timeouts and the like, the other piece of work that landed yesterday is support for preceding the network config. So that's work that Matthias did, so another employee at Future Fusion, did last week, cleaned it up this week, which implements a new network, either YAML or JSON file in the seed partition that gets picked up on boot, and then that applies the network config. It also automatically applies like a basic network config if none is provided. So we can actually just check that in the main commit here, where it's basically the systemd network, the interactions, and yeah, if no config is provided to the generate function, then it goes onto a fallback logic, which does DHCP on any Ethernet device that can be found, basically. So that works pretty well. That's just landed. There's going to be a bunch of tweaks on top of that to allow for anything we forgot when designing the data that can be provided. Actually, if we go look at the issue that this resolved over here, this guy. There are some examples for what the YAML syntax kind of looks like. So the first example here would be a machine with two physical network cards that we want to. What are we doing actually here? Oh yeah, okay. Yeah, so it's got three network cards basically. So it's got one that goes to a storage array. It's got a second card that also goes to, in this case, another, well, potentially the same storage array, but on a different network. That's pretty common if you're accessing NVMe over TCP or something along those lines, to have two completely different paths, different subnets, different switches. So you get that. There is an indication here for what this thing is for. So it's marked as being for storage. And then there's also a bond that's defined. So it effectively picks up the two interfaces with those MAC addresses. We use the MAC address as the kind of unique identifier that we use to select the actual interfaces rather than relying on their names, which keeps changing. So we use the MAC address, find those two interfaces, then that comes with IPv4, IPv6, and with routes. So this one is all statically configured. It also puts, effectively sets that this management, so this IP address and everything, must be put on VLAN 100. So that effectively that configures what the main VLAN, the primary VLAN is for that bond to VLAN 100. Then once that's done, we also create an additional VLAN on top of this. So on top of the parent, on top of the management bond in this case, which is the uplink for Oven, and it's got a role to match there. So Yeah, the roles currently, I think I don't actually use internally yet, but they're gonna become pretty important because things like if you've got the instances role, then it means we probably want Incus to be configured to use that. If it's of an uplink, we're probably gonna need to automatically configure some Open vSwitch options and like. If it's storage, then typically you'd want to refuse putting any instance on that. And it's really just for the host to talk to the storage array, and that's it. And then we've got some more examples for, in this case, what it looks like if you want to do just dynamic addressing. So this is a system with just a single NIC that we want to be used for both management and instances. And the way it's defined is actually effectively it says do DHCP v4 for IPv4, do stateless auto address configuration for IPv6, and then use that data for the default routes on IPv4 and IPv6. So that's closer to kind of the out-of-the-box default of just pick an IP address and move on. So that's been implemented now inside of IncusOS, and that got merged yesterday. So let's, if I keep going back, that's what we were looking at with the list of commits here. Basically, that branch does a few things. A bit of cleanup, so effectively making Golang CI be a bit less picky. Then implementing, I think I mentioned that one last week. I didn't like a very long list of, you don't have a seed if you either don't have a seed partition or don't have a data file on there, or don't have the file system on there, or don't have the file on there. Having to do that repeatedly was just getting kind of silly. So I implemented an is missing function, which is now doing all three checks, and that makes things a bit cleaner. So I finally got around to doing that one. I was complaining about it last week. Then we've got better support for if a machine boots without secure boot being configured properly. Now we get an error being returned to mention that. We still have a bit of a problem that currently there's no way to actually see the errors on screen, but that's going to be another piece of work we'll be looking at probably the next couple of weeks, to have IncusOS know how to drive the text console on the server to effectively wipe the screen and then push, like show that this is IncusOS running, that's the IP address it's running on, and those are kind of the critical state messages. So it should be able to handle that way. So it was just a bit of a tweak for that one. And then extending the systemd logic at Hibernate to have a restart unit, because we only had enable and start, I think. So now we've got restart as well, which is needed to restart networkd whenever we apply network config changes. Then a bit more refactoring around how we access the seed data. So I'm going to go through that one. Then adding network data itself, can go through that too. Then the systemd networkd part is just taking that data and generating files within /run, and then restart networkd. And after that, there were a few small changes, like obviously our default network config had to go away from the image, so that's been done. Then network config is now applied on startup, and part of that also means changing when IncusOS starts, because it used to start after the network is online. Now it needs to start prior to the network being online, since it's the one taking care of the network config. All right. So that's the change for kind of refactoring the way we access the seed, and it's going to be relevant for today's work. The initial implementation I did had like I can see like a get applications function. And then internally, that get applications was doing a bunch of things. Like it was looking for the seed partition, reading it, doing the tar reader, blah, blah, blah. It was doing a lot of stuff. And now we need that kind of logic in other places. So what we've done is we've got an internal parse file contents function that we can just effectively parse what the partition is. So that's just provided by the caller. That's mostly so we can do testing on this stuff. And then we can pass it the name of the file we'd like to pass. So in this case, it's applications. And then pass in a struct that we'd like to fill with the content of that file. And then what happens is, what's the new function? It's here. So then that function does the same stuff we did before, which is, open the partition, check that it's a tarball. If it's a tarball, open the tar reader, go through the files. Once we find the right file, parse it. And that's the part that's slightly new is when I implemented it last week before, yeah, 2 weeks ago, we only supported JSON. So now it actually checks for both. It will check for only one file. Is there a JSON version? If there is, uses that. If there isn't, but there's YAML, it's going to use that instead. So that means for all of the seed files, we can either provide it as JSON or YAML, depending on what's convenient for the user. And then once the file is open, we just literally pass the file through a decoder into the struct we provided, and that's it. So that's for that change. Then once that got put in place, we could then do it for networking. So we've got a new file that does the get network call, which then uses a network config and fills it in with whatever is in the network file. And now that network config type is effectively the representation of all the fields that I showed on GitHub earlier. Actually, just scrolling through this, I just saw something trivial that I can fix right after this, which is the missing labels on some of the fields, because everything is tagged as YAML in here, but we need to also do JSON. And then on the JSON ones, I don't think we've got the YAML tag, so we need to make sure we've got both everywhere. I'll do that quick commit right after going through the remaining commit here. And so the last change is effectively on startup now, very early on startup. We get the network config and then apply it. And at that point, we should have mostly working networking, and then we can keep going with the rest. So that's how that works. Now, as mentioned, there's an easy fix I just wanted to do quickly while I noticed it, which is we've got a bunch of YAML tags in IncusOS. Yeah, all of these guys. So all of these need to have a matching JSON one. So if we go look and look at YAML, we need to do JSON and the exact same thing. So that's going to give you an opportunity to actually look at what all of the fields are, but that's the main struct we saw on GitHub. And I'm going to try and do that without doing typos. So, could probably script it, but I think there are just few enough that it's not worth the effort. So yeah, basically similar to what we do for Incus with all of our metadata, all of our API fields, we effectively do the same where we need to provide both the names in both cases. That's slightly unfortunate. It would be cool if either the JSON parser or the YAML parser would look at the other as kind of its default. But I was having a discussion yesterday, and it doesn't look like this is done. So I can just go and set them all and hope there's no typo. There's a question around what is the dash syntax. I don't actually know. I suspect it is to not have the field be part of the struct, but in that case, we don't need that at all because it's not the inline syntax. I think it's probably equivalent to nothing. Let's actually go with just nothing, and then we'll see if that causes any issues. Because that looks like an internal field. The hardware address here is effectively... actually, hold on. Network interface, name, VLAN, addresses, routes, HW other. That's an actual field, I think, isn't it? Let me recheck the design here. So if we look for an individual interface, yeah, we did have HWR there. So I'm kind of confused here as to why it's Let me check how it's handled. Maybe there's something interesting going on here. HW had a unmarshal YAML. Okay. Yeah, so there's special handling effectively for that. Can see that when we do the unmarshalling for YAML, then we go through this logic here. That keeps both the original value, so the string value, and the MAC address value. That might end up being a slightly bigger change than I hoped then. Because I would probably, I mean, the way I would most likely do it is by keeping this as a string at that point. And then handling the translation to that, from that to a actual hardware MAC address, like a proper struct for the MAC address just internally, to make things easier, because otherwise we're gonna need custom and marshalling for both JSON and YAML. I don't think that's gonna be too pleasant. It's gonna be too likely that we're gonna just miss something at some point, and that's gonna cause breakages. So I think the way I would do it is by doing this. I'm gonna have to do the same on this one. I don't even know that it's why we're doing the parsing into a native type, given that it's not like we're doing much logic on it. It just gets pushed straight into a text file for systemd networkd. So I don't know that this is what was the reason for that. I'm gonna have to look into it. Just keep converting things, and then I'm gonna remove the custom marshallers, and that's gonna break things, which is fine. And then you can just go and fix whatever broke. So that's the MTU, and those are roles. Okay, so that's fine. What else do we have? So then we've got, yeah, the custom marshal and marshal. Yeah, and so there's Jared is saying that like this might help for like error test, like validation effectively. And yeah, it would, because then during unmarshal we could return an error. I don't know that this is worth the effort, because the main downside here is that now, like in this case for bonds with members, now we need custom loop that adds everything, but more worryingly, unmarshal for something like the network bond struct here. Now we need to manually set all of the fields. So if we add a new field, we're gonna add it to the struct. We're gonna think it's gonna get filled automatically like it normally does for JSON or YAML, and then it won't. And we're gonna get very confused as to why things are not properly propagated. So yeah, my gut feeling is that we should just remove all of the custom marshallers. That's gonna remove like 3/4 of the file basically, because otherwise it's just struct if we remove that. That might make things actually easier. I'm checking also what's going on with the address type and custom address and all that stuff here. Are we using that? Yeah, it's a list of custom address. Okay, but the custom address is then, it's defined as a struct. So since it's defined as a struct, it won't be able to unmarshal to it. So that's gonna be a problem. And I think a route probably has the same, yeah, the same issue. Yeah, that's making things a bit harder. Yeah, not too sure how to handle that one, because like the code as it is already getting quite long because of the YAML marshal and marshal, and as before we add JSON. Like the moment we need to also add JSON to the mix, we're doubling all of that footprint and doubling the chances of things going wrong. So I'm not convinced that this is the right thing to do. So let me check. So addresses was just supposed to be a string, right? Yeah, addresses are just strings. I mean, they're supposed to be CIDR subnets, so yeah, we need to validate that for sure. But that can be done in different ways. Like if we would just want validation, I would rather have a validate function on the struct that does then validate the value and just make sure that immediately after parsing, we effectively call validate, which then checks everything. Rather than doing it during Marshall and Marshall, because now it's a lot of logic we need to keep track of. So this is effectively a string, so we can remove the custom type. A root is a bit different because that is not a string. This is an actual struct, I'm pretty sure. Like for a rat on there, each rat has a to and via value. So that we need to change. Okay, so custom address is here. And yeah, the benefit here was that custom address, we could then immediately tell whether it's what type it is, what family it is, whether it's also like the special values for Slack and DHCP, well, DHCP v4, DHCP v6, and Slack are all defined there. So that would have been convenient. Let me just see, because having constants for those names, that would be a useful thing to have. But yeah. For now, I think I'm just gonna clean that stuff, just remove that stuff, and I can always bring it back later. Okay, so route, this one has a to and a via. Both of them would just treat them as strings for now. Okay. I feel slightly bad for Matthias because he probably spent a bunch of time doing all the fancy parsing and validation and everything, and I'm kind of ripping it all out at this point. But the reality is that if we need to duplicate all that mess for JSON, it's gonna get very unpleasant. And I don't know if it works the exact same way with JSON. Like if it does, it might not be too bad. We might be able to have a single unmarshal function and then just have unmarshal JSON and marshal YAML be a very thin layer on top of that. So yeah, I'll say. So I think that's all the structs we need. The rest is all the marshal and marshal logic. So I can remove all of that. And see just how badly I broke things. This was supposed to be an easy fix, like an easy just add the JSON tags, and that turned into a bit like a bit of a bigger beast right now. But let's see. Right, okay, so the types, we don't need any of the imports, that makes sense. They're all basically pure Go types at this point. So no need for importing anything, that's fine. And then the problems start. And we'll see if I actually want to go through all that stuff now, or if I'm just gonna fix all of those offline, because that might take a little while to fix. Some of the stuff is pretty obvious. The hardware address .string thing, that's no longer needed. We don't need to .string anything if it's already a string. So that's pretty straightforward. But I suspect there's gonna be some others that are not gonna be as easy. Just looking for all of the obvious ones for now. Because I already saw something was using some of the constants. Yeah, there we go. Root of via the type, yeah, tweet to. Yeah, so that's one of those where currently the type of gateway here is well, it doesn't work anymore that way. So what we can do is just do it as through a string. So effectively, if it's via DHCP4, then this is this. If it's via, was it Slack? Yeah. Then it's this. So that should have fixed that guy, probably. Yeah, it did. Okay, cool. What else do we have? 248. So this one takes a custom address. It's no longer gonna take a custom address, gonna take a list of strings. And that's probably gonna cause a bunch of problems because like it looks at the type again, which it's not gonna be a thing anymore. So same thing, we're gonna look on the actual value and we support DHCP4, DHCP6, and snag. Okay, let's do that. Well, that actually turned out to be quite a bit easier than I expected. So that's good. Now I suspect the problem is that we do have some tests actually for this stuff. And I've got a suspicion that the tests are gonna get quite mad at me for this stuff. Let's see. Oh yeah, tests are quite mad. I suspect because a lot of the tests probably specifically check the marshalling, unmarshalling syntax. And none of that's gonna work properly anymore now. So what does it do? It takes a network D config, parses it, then we want to equal, okay. Well, so the first part is the same thing, basically. All of the string stuff we can remove probably safely. I'm still gonna look at them all instead of just doing a regexp to remove them all, which would have been the easy thing to do. I like to still have an idea for whether things are gonna work or not. Like some of that won't, like the IP and mask stuff, they are not separate entities right now, so that's not gonna work anymore. It's just a string, but some of those tests can probably just be removed since we don't have the fancier internal types anymore, we just have strings. So let's see what the damage looks like now. Okay, that's a bit more manageable. Line 90. Yeah, so this is checking for each of them, the mask and field. It's also not really like having the mask in this format is kind of unusual. We wouldn't probably just want CIDR anyways as far as what we pass through. So I don't know how useful having it in that format is. Okay, so now we're getting further. It's actually building, it's just complaining afterwards. Okay, so when the MAC address was passed, the case was changed from uppercase down to, well, yeah, uppercase down to lowercase, and now it's failing because of that. So the good thing is we've got the test in place, so it's just a matter of, I mean, assume, let's see what the test actually checks. If it checks a resulting config, then we can fix the generation function to bring the case down. If not, line was it for the test? It was 92. Okay, 92. Okay, so it's yeah, on purpose checks that it's brought to lowercase, but it checks the output of the unmarshaled, so it checks the unmarshalling instead. That's not gonna work at that stage of the unmarshal. Values are as they are in the file. We no longer alter anything, which is frankly kind of how I like it. If like when I feed JSON or YAML, the structs I get out of it, I'd like it to match the data provided by the user instead of having things be already altered at that stage. I think it's kind of cleaner to do it later on. So things went further. Network test 99. What's going on there? I promise we're gonna eventually get back to what we actually were supposed to be doing today. Should have 2 items but has 0. Okay. And why would that be? So that looks like an actual bug. Bonds 0, members 2. So what config is it using? It's using config 1. It's this one. Bonds. So that's the first bond, and it expects members to have 2 entries, which yeah, it definitely should. Let's go see if I messed up the YAML on that one, maybe. See network types. What's going on here? Oh, yeah, right. I'm in the wrong folder. Okay, so if I go look at network types, members, what's going on with members? Oh, yeah, that's way wrong. Yay for test. All right. That's what I get for copy pasting and not reading what I'm doing. Okay, so that test should be quite a bit happier now. And now it's complaining about the name of the link. Okay, so that's actual generated code at that point, I think. Let's see, 148, what's in there? What are we checking? Yeah, so we do call generate file contents and then we check it. So there the MAC address needs to be mangled. So let me go and do that in that function. So basically, whenever we process inside of the network the generation function, when we process a hardware address, like there's already, in this case, we're already stripping it. So we need to also strings that to lower this thing. And that's fine here. That's the MAC address. So again, strings dot to lower. It doesn't, I mean, the reality is it doesn't really matter at that, in that particular spot. I'm actually half tempted to just leave it. Like we want it consistent for the interface name. So here it matters. In here, it's the user provided value, whether they provided it with uppercase or not. It doesn't make a difference. So I don't think we should mangle it there actually. Let me check if there's anywhere else where we should do, yes, there's another stripped one here. So again, to lower on this guy, that makes sense. And is there any more? No, we're good. Okay, so I expect that that's probably gonna break some of the tests still that need fixing. Yeah, like this MAC address one here, it's like it's no longer being brought to lowercase, but that's actually how I would like it, I think, in this scenario. So let's go and fix that. I suspect this one probably has the same problem, so let's just go and do it already. And just to be annoying, it won't, and I'll actually have caused more failure, but who knows. Okay, so it is complaining about 160 now. Yeah, okay, so it looks like they are all capitalized in the YAML and all tested as lowercase in the test. That's fine. So that's clear now. Next step is 124. Okay, this again, MAC address in the format it lands into the file, well, or the way it's in the struct in this case. Need to fix that. Okay, and last, okay, this one is actually wrong. All right. Well, actually, no, it's not wrong. Yeah, it used to be wrong. The gateway for a route should not need a prefix. Like the destination does, but the gateway doesn't. So I think the new value is actually correct here. I don't know. Like, I don't think the system cares either way. It's fine, but not having the /42 or the /128 for the destination, for the gateway is actually correct, I think. Destination gateway here. There. Okay, getting there. And one more MAC address, line 213. So that's another one. Yeah, and I think the one below will probably be the exact same issue again. Because that's not a device name, that's a value that lands directly in the config. So this needs to be passed. Okay, so we're good. Let's do a static analysis run just to make sure that I didn't break anything with that now. Okay, it's mad. Is not aligned, should be okay. What's it complaining? Did I already run Go format? Because if I didn't, that might be the issue. No, that's not the issue. Okay, well, I'm gonna have some fun fixing that. Right, so there is a what's going on there? Generally intent isn't used for okay. Right, so there's a question from Jared around what's going on with the gateway thing. So the gateways, like when you set a route, and I mean you can normally see that in your routing table. You always have the destination network, which most of the time is a full subnet. So those you want the CIDR notation to know whether it's just an individual address, like a /32 for IPv4 or /128 for IPv6, or if it's a larger subnet like a /16 or /24 or whatever I've got here. But then the destination through which to go, which is only visible on the first one, you're not sending it through a subnet, you're sending it through a specific router. And so the destination, the via value can only be an individual IP address. It seems like networkd tolerates being passed a CIDR so long as it's a single address, so like a /32 or /128, but it doesn't really make sense. So yeah, in this scenario, the more complex unmarshalling logic was actually leading to a value that looks wrong. I'm just gonna fix the rest of those linting things real quick, and then we should be good with that particular bit of cleanup. Well, kinda. There's still one more thing I need to do after that. Let's go network day 254. So it's just complaining that we've got no lint statements that are no longer needed because we changed another type of that. Did I do the right two? We'll see. Did I? Okay. So just complaining about more things. We can fix the 282 one. So this guy. Is there any more? Like I don't really like turning off linting that way if we can avoid it. Yeah, the GoSec stuff, I'll see what I can do about it because it's, if we need to do it every time we open a file, it's not gonna be useful. It's gonna turn it off globally, but okay. All right, now it's just complaining that we can simplify the if else in some part of the code here. Okay, what's it complaining about exactly? Rewrite if else to switch statement. All right, yeah, okay. I'm not actually sure how to do that in this case. Was it one of those that was also overridden? Because if so, that one might actually have a strong point for being overridden. Yeah, no lint co-critic, yeah. Because in this particular case, like swing like a case statement when you're checking both variables at the same time, it's not the most intuitive. So I think it makes sense to keep that one. Okay, cool. Now we're just all of the complaints around the alignment, which, well, let's see what we can do about that. Line 40, come on, wrong folder. Line 44, what's going on there? So I think it's basically saying that like we should try and align them that way, which I would agree would be nicer. Is it happy if I do that? 44, it's still complaining. Tag is not aligned, should be JSON via, oh, okay, it wants it the other way around. Oh, crap. Okay. It's basically saying it wants it in alphabetical order. So JSON first, YAML next. Okay, so let's do little switcheroo. So let's just do JSON to foo. Then we can do YAML to JSON. And then we can do foo to YAML. There. Did that work? Okay, so the ordering I think it's happy with, but now it also actually wants the alignment, I think, on top of that. Okay. Yeah, okay, so it looks like there is that. Cool. Alright, well, I'm gonna need to align all of these guys. So we need to take the rightmost of the batch and then align everything underneath it. Like, I don't know how much I care about the old JSON being first before YAML part. I think it makes sense, it's fine. But the vertical alignment piece is quite useful, I think. So it's one of those where maybe the original tool that does that actually has a mechanism to do in-place correction that would just have reshuffled the file. I don't know that we can easily do that with Golang CI the way we've got it configured here. So it's just kind of annoying because it's a bit of manual work to go and realign everyone here. But luckily there are not that many fields, so it's going to be a pretty quick process to make everything behave. Then see if the test's still clear, which they should, because it's just, you know, alignment stuff really. Yay, okay, so that's good. And then IncusOS go test. And everything is still clear, so good. All right. So I mean, fundamentally the change is just one thing, which is internal seed allow network seed to be JSON, because that's effectively what caused this whole stuff. Is need to remove the marshalling, need to change the types, need to change all that stuff so that we can do either JSON or YAML and everything works. So that's done. Now I think I effectively have some files that have the reverse problem. In the application one here, where we only have JSON, we don't have YAML. So need to just do the opposite and add the YAML equivalents for all of those. I'm gonna already align them correctly. And that should be that. So static analysis, it's happy. Go test, still happy. And I can just commit that as allow applications seed to be YAML. So now we've covered kind of both sides of this, and that should be nice and consistent at last. And there's a question from Jared about like, does it make sense to add a test case for JSON? Yeah, it does. We definitely should test that. We could test it kind of indirectly in theory by taking the struct, moving it to JSON, re-importing it basically. Well, no, actually that wouldn't work, because if we do that, then we don't test the tags. Yeah, we would probably need another value, another test value, but JSON instead of YAML to test all of that. Probably going to be something for later, because I actually want to spend a bit of time today doing what I actually meant to do today, which wasn't really this. But yeah, let's look at what it is we actually want to do today. So as mentioned, and as you've seen, the seed logic currently, it does applications and it does and it does network. What we need to do is actually do Incus as well. That's probably going to need more reshuffling down the line, because we're going to support more applications than just running Incus on top of this stuff. So we might want to turn that into like sub packages or something like that. But for the time being, let's just make it pretty simple. Take applications.go seed and call it incus.go, and implement effectively. So we don't need the structs, because in the case of Incus, that's something that already exists. That's the Incus preseed data. So we can do get Incus, extracts the Incus preseed from the seed data. And And when we do that, what we actually want to return is the correct struct from Incus itself. So let's go look at the Incus code base real quick. So in the case of Incus, we've got the shared API package that includes all of our public structs. And in this case, we want init over here, which then has that init precede struct that includes basically everything, everything that we need, like all of the fields and everything. So that's the type we actually do want to return. So it is a API dot init precede. We should actually call it Incus API or something along those lines, I think. It's Incus API, and this is GitHub Incus v6 shared API. Okay. And get the precede. And again, it's just Incus API init precede is the type. We unpack into precede. We want the file to be named Incus, and then we return the precede. So let's see. That's gonna require a slight change to dependencies. So we should actually do I have update go mod? No, not yet. Okay. That's another make target that we usually have in our projects, but it's not implemented here yet. So let's just download dependencies. It's not, oh, well, I guess, yeah, we should just do the package itself. So put everything we need. There we go. So now we've got Incus that's been pulled into the Go mod file. So that's what we needed for this one. And then let's try building IncusOS. Cannot use precede value of type. Okay. Right. All right. Yeah, I'm doing this, which is wrong. So actually, the way we normally do it is that we don't do a pointer at that stage. We do a pointer later on. There we go. Okay, so that just adds the most basic parsing logic. We can add that. IncusOS seed, add support for Incus precede. So that gets committed, and then we update Go mod. Okay, let's just see if static analysis is still happy. It is not. Let's go make it happy. Internal seed Incus. Import alias naming. And what does it want? Must match. Yeah, no. It does. It really doesn't like capital letters for some reason. Even though I think capitalizing API here made it more readable, but anyways, let's fix that. Okay. Just gonna go and fix up that commit here. Alright, and static analysis should be happy. Yes. Go tests should still be happy too. Yep. All right, so that part is in place. So now all it does is it looks for like a either incus.yaml or incus.json file, and we've got a function to retrieve it. It's not terribly useful because it doesn't actually do anything with it, but you know we can retrieve the data at least. That gives us the struct, which I think that's where things that might get slightly tricky, but I need to check the Incus code for that. Like there are effectively two ways of handling that. One is, cool, we've got the struct, and basically the first thing we do with that struct is we write it back down to disk, or we pass it through std to Incus admin init precede, and we just call it through the command line. Another option could be to do it natively through the client. I just don't remember if that's actually something that can be done in a reasonable way. So let's see what the precede function actually does normally. So when we call precede, so the precede command, it reads from stdin, it unmarshals in there, but it just, yeah, so run precede just returns the precede. It doesn't apply it. So we need to look at what calls run precede, which is from the main init function. And then we get the config data. Okay, cool. And then once we've got the config data, we need to apply it, which is where things get a bit more hairy because we've got some files on disk to go read and validate. And what do we do at the end? Okay, apply server precede when we pass the config. Okay, so apply server precede is a function from the API then, is that right? Let's see. See if it is, we can still do that. Yeah, it does. Okay, so that's not too bad. Yeah, we can definitely do that then. It's just all of the intermediate logic around cluster handling and stuff might potentially be problematic. But that might be a strong case for not having that logic be there in the precede, but then instead be there in the CLI, but instead be in the client package instead. So anyway, the path stuff, that's not gonna apply to the precede because precedes can't contain files, so that's not an issue. Okay, so now if a precede was to contain a token, it does a token decode, sets the name, sets the addresses, sets all that stuff. Yeah, that chunk here, that feels like it would need to be moved away from this and into the client logic. Doesn't really matter right now because the reality is that we're going to be dealing mostly with standalone servers at this stage, but that's still something that kind of needs tweaking. Same thing here, the clustering setting of the initial address, that shouldn't be in the CLI. All that stuff should be in apply server precede. So yeah, there's going to be a bit of cleanup needed on that one within Incus. But for now, we can just use apply server precede to apply that config. So let's see if we can't do that quickly and do it the ugly way, to be clear, because all of that needs to be moved. Like there needs to be effectively a bunch of standard functions for the applications. Like right now, if we look at what we have, we've got that logic of, hey, are we doing Incus? Yes, okay, cool. Then we need to start it up. It's that kind of like that kind of hardcoded logic will need to go. What we need to figure out now in here is, okay, we've enabled Incus, it's running. So from this stage, from this point on, we could load the precede. But the question is has Incus already been configured or not? I can't tell that with what we have right now. So the way I would do it, I think, is extending what we have in the state. So if we look at this, at our state file, each application, so we've got a map of string to applications. Where are the structs? Struct. And the application currently just has a version string. So I think what we would do is do an initialized Boolean. And this one is an ARM file, so it only needs JSON. There's no YAML to be done in here. Yeah, so if we do that, I'm just checking if it does the alignment. Yeah, there we go. Okay, so now we've got an initialized field that we can mess with, which will let us check, in theory, if we can, like if we need to initialize it or not. So it shows starting Incus, it started, okay, that's fine. And then if, so we'll just call that Incus app if Incus app.initialized, and actually starting Incus, now that we've got the app, we can show the versions. We can do version, Incus app.version where we add it. And if it's not initialized, and if I fix my typo here, then we can go through loading the preseed. So the first thing to do here would be Incus preseed error, and then it's from the seed.get Incus function with context, and we need to pass in the partition we want to read it from. So it's this guy. Oops, where's my code now? Oh, here. Okay, so we pass the partition we're supposed to read it from. That's fine. And then we need to actually deal with the errors coming from that stuff too. So it's that chunk. Just to say, so if the errors is not null and it's not missing, then we should return the error. It's fine. And then if Incus preseed is not null, then we need to actually go and apply it. So for that, we need to use the Incus API, which we don't currently have imported here. So we need to do that. V6 shared API, shared client, not shared API, actually we need the client. Okay. And what's the easy way to do that again? It's like connect Unix, I think is the way to go. So C error. I should probably actually import it as Incus client so it's not confusing. No, it's gonna show up, never mind. Incus client is named Incus internally. I should just put the tag here that this is gonna be named Incus. Yeah, but it won't let me do the capital stuff, never mind. So we'll put it that way. Cool, so Incus, and then the function I think is connect Unix, but let's see. No, it just connect Incus, and then, so that takes a URL. Is it connect Incus Unix? It is, okay, cool. So connect Incus Unix, and normally no path, no args, that still works. That just doesn't let us, like it uses the default path and no fancy connection settings, which is fine for what we need. Handle the errors, and then actual preseed apply. That's done with that function we're looking at. Where was I looking at that? Oh yeah. Oh yeah, apply server preseed there. So this guy. So if we do that, and then we pass the actual preseed, which we should have as Incus preseed here, and then handle errors, and we should be good. And it's complaining quite a bit. So I need to update Go mode again to pull in the Go client this time. We pulled the API last time. This time it's the client that needs to come along. It sounds like it's pulling a few dependencies. It's taking a little while. Come on. I think this particular change is like pulling all of the Incus depths. Yeah, that's gonna increase the size of IncusOS a tiny bit because it's gonna pull clients for OIDC and a bunch of other things, which it's fine. Like we're gonna basically use a bunch of that stuff within IncusOS down the line anyways. So it's growing quite significantly in size through that is not the biggest deal. Okay, it's complaining about this being a pointer when it doesn't want one. So let's fix that. And now it builds. Just out of interest, what are we looking as far as size delta here? So if I go in an IncusOS VM that's running, the binary size for the daemon was 7 megs. The unstripped size for the daemon now is 14 megs. And if we strip it, it goes down to 9. Okay, so 2 more megs to pull all of the Incus stuff. That's not too bad. And also, like this daemon didn't have any of the network D stuff in it yet. So yeah, a couple of megs extra. That's fine. All right. So now we effectively have the logic in place. The question is whether it works. So first thing first, we're gonna need a new image. So let's build ourselves one to test this stuff. So let's just do make. And that's gonna take a little while because yeah, it needs to build an image from scratch with the new daemon, the new everything in it. So I'm gonna let that happen. And then I'm gonna need to actually load a seed. So for that, what can we do as far as a bit of an example seed? So if we go in here, seed. Now we should be able to do, just for kicks, do YAML for the applications. Just rechecking the syntax for that. So if we do seed applications, I think there's also an example here. No, the test doesn't really help us. So anyway, for applications, yeah, it's the root of the file is a struct with version and then a list of applications underneath. Okay. So let's do version 1 applications like that, and then name. We want debug and we want Incus. And that's all we need for that guy, so that's good. And then I'm not going to touch networks. I just want to see it use the default fallback mechanism for it. So we'll do that. And then for Incus, we should be able to do init dump, admin init dump, which then dumps a bunch of, well, basically my current system. It's a bit more verbose than I would like. Let me just pick a random test VM I've got instead and use that. So Incus admin init dump. And this one should be a bit less complex, so we can use that. And we're gonna do YAML for that guy too. And just pull that data and clean it up a bit. Okay, so that's a pre-seed. It will bring us IPv4, IPv6, storage pool, using directory. So we can actually, let's try and have a bit of fun here. So let's actually use the ZFS and the partition we've got set up for that. So let's do, no need for a pool name, that should be automatic. But if I go into my test IncusOS VM, like we pre-create some partitions on boot with whatever space was left. So if we look at by part label, there should be a local data partition that's not used that we can then feed to ZFS to put stuff on. So let's do that. Local storage ZFS. Let's do something like that. Name, let's call that default. So for this one, let's just use something more memorable so that we can see that this is indeed ours and not a random thing. FD42 is just do 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. So it's again obvious that it's ours. Incus BR0. Actually, let's call that local because that's what we normally would do in production. And then we've got the default profile, so default Incus profile, ETH0 on Incus BR0, that's good. And then the path would go onto local, the root disk would go into local. Projects, what do we have? Default Incus project, yeah, but that gets created automatically anyway, so we don't need to go through that. Okay. So I think that should do the trick. Actually, I'm pretty sure this is not necessary. So if we just remove that, it will figure it out on its own. Same thing for the volumes list. Don't need to put that, don't need to put config. Actually, for config we can. So let's make it so we listen on all IPv6 addresses out of the box. Let's do that. Okay. So that should be it. Let's go ahead and write that as a seed tarball. So seed.tar, all the YAML files. Okay. The VM image was created, so we can do make test, which is going to replace my VM with that one. It's going to start it up with no seed in place at that point in time. But we can kind of reset things. What I'm going to do is just transfer the seed, write it to the partition, wipe the state, and then reboot, which should then trigger IncusOS to do a kind of first boot config from scratch. Actually, we should also push the applications for that to be true, but let's see. I might not even need to reboot, actually. I might just need to reset it. Okay, it's just doing its first boot auto repartitioning. Okay, and we're good. Now let's transfer the seed over. Push seed.tar into Incus. Test IncusOS in the root folder. There we go. And now the seed, I can write it to by part label seed data. Okay. And we're going to wipe any existing state for IncusOS. There we go. And then proceed with uploading of the applications. So if we do test applications, I'm in the wrong folder. Where am I? Yeah. Okay. So that's pushing both Incus and the debug application over, and then restarts IncusOSD. So it should start doing its job at that point. Let's see, John all IncusOSD. What's it been up to? Okay, so that's ran just 20 seconds ago. Getting local OS info, platform keyring. So yeah, starting up, mode dev, up, Incus. System is already running latest OS release, refreshing system extensions, refreshing users. So it's acting as if it didn't see the seeds data, basically. That's interesting. I might just have messed something up in there. So let's see, by path labels, seed data. Okay, applications YAML, Incus YAML. Okay, so on startup, it should have Incus, come on, Incus OSD, come on, Incus OSD. I already have it open, really? Okay. So it should have done the get applications call here. Which it looks like it didn't, which is kind of weird. Like we do have an update provider in place. shows like system is already running latest release. So yeah, that hints that we did go through some of that. Yeah, so we did call into update, and it's as if it didn't pull anything from the applications, because normally it should have something into the to install list, and then after saying that there's like no update, it would have gone through this list, so doing get application for each of the names, and then either say that it's already up to date, or it would have showed downloading system extension, which it didn't. So it very much suggests that the list of applications, so the to install list here is empty. Now if we look, to install would be empty and then get stuff appended to it, but only if we did find a seed file and effectively no data should we end up in this situation. So let's see. What did I mess up with the seed file effectively? Applications. Okay, that doesn't strike me as wrong. Is there an issue with the data in here? Did I typo something in here? Not that I can tell. No, that looks correct. So that's not the issue. Okay, time for a bit of debugging then. Just go see get applications. Just trying to figure out what's going on here. So this is seed, get applications. This is provider, get applications. Okay, so that's the one I want. It's basically if state the applications is 0, which it should be. Let's just add some debugging. So slog.error. I don't know if I need to format that or not with slog, so let's just do the formatting anyways. And then, so that will tell us whether there's anything there. And then dumps the actual seed data. Okay, IncusOS, and then let's just push the binary directly into test IncusOS and run it by hand. So I'm just gonna stop IncusOS and run it from the local folder and see what's up. All right, so the list of applications is an empty map, and then the seed is completely empty. So that's weird. It's gonna behaving as if it's missing, basically. Just make it slightly happier for logging. Okay, let's run that again. Right, it confirms the state is still empty. Seed has no error, but also returns a completely empty struct. So that's not good. What's causing this mess? because that basically means that here we are calling get applications, we're getting data back, just completely empty data. So let's go add more debugging inside of get applications and what's going on there. State, not state, seed applications.go. All right. I mean, it's going to be the same thing here. Like, we're not going to get any more details from that spot. I'm going to need to go into the file parsing itself to see what's going on there. Okay. So it's a YAML file. So I would expect to see it here. So file name is, let's do that. Oh, hold on a sec. Is that the issue? Because like, we already passed a pointer from the previous call, so within passing a pointer to a pointer, it's kind of that might be the problem here. So let's see. Let's just push that. So it's gonna have both more debugging and also, yeah, that was the issue. Okay, so now it's downloading stuff, applying it, starting Incus, found YAML again for Incus. So it's trying to precede it now, possibly. It might have done it since it's a daemon these days. So let's see, what do we have? Storage list. Yeah, that worked. Okay, let's just tidy up the fix then. This question of like, why did type checking not catch the issue? Because the type is any for both the parent function and for the unmarshaled logic. It takes an any type, so you can pass a pointer to a pointer to a pointer to a pointer, but it's just gonna get confused and end up filling the wrong thing. So yeah, not completely obvious. So something actually messed up yesterday, and then we missed it in testing, so that's slightly annoying. What other debugging did I put? I think I had in the main daemon itself. Yeah, bunch of stuff here. All right, so what does that look like? So the fix for the seed, I need to push that one because that's relevant right now. So Incus OSD seed fix and marshalling. Okay. Then in the state, we want keep track of application initialization. Yep, that's right. And that's in state. Okay, and I actually just noticed, like by just thinking about that now, that I forgot to actually mark the application as initialized once it is. So here we need to actually go and update the state so that this works correctly. So as the applications incus dot initialized true, so that in theory we don't run that logic again. Now let's try to make the binary again. Cannot assign to struct field initialized in. Sure, if you say so. Incus app initialized true, and then just gonna override the app. That would work. There we go. And let's see, so if I push, whoops, if I stop IncusOS, push and start it again, it should not try to run through this again. Okay, well, okay, bad example. It did it in this case because when it never got marked as having been run due to me missing that logic earlier. So what I'm gonna do is I'm just gonna run a new test. So it's gonna get me a clean VM again. And this time I'm gonna push, well, stop IncusOS, push the new seed, put it in place, wipe the state, run IncusOS again, and just make sure it does the right thing. And that if we run it a second time, it still does the right thing. And then this is going to be the end of this stream. It's going to have been a bit longer than expected. Again, I tried to keep them around an hour. It's going to be an hour and a half, but quite a bit got done, so I'm happy with that. And the actual piece of, initializing Incus has actually been pretty straightforward overall. Just look like the seed passing and passing it to Incus itself was pretty straightforward and just worked, so that's good. All right, so let's stop IncusOS. Oops, IncusOS. Come on, IncusOS. There we go. Valib IncusOS. Push the new updated binary in, and we need the seed tarball as well. And we also need the applications to be pushed. So seed needs to go into its partition, part label seed. There we go. That can get removed. And actually, let me put that IncusOS as an override on top of the system one. So that bind. Sorry. What now? There. Okay. So IncusOS, let's look at the log, systemd log effectively. And then if I do test applications, it should push the new binary files, then restart IncusOS, which is then gonna pick up the pre-seed and apply everything in theory, let's say. All right. And I think that worked. Need a bit more logging actually in here, because we just apply the preset but don't really log anything. So let's do that. Applying Incus preseed there. Okay, so we're gonna have that bit of debugging in place now. And yeah, if I just get another shell in there, IncusOS bash. All right, so now what do we have? Well, what we should have is systemd sysext. We should have both debug and Incus loaded, so that's good, it's in place. And now on the Incus side, we don't have any instances, but we do have storage pool got created, we've got a network that got created, the default profile has been configured, and the daemon should be listening on the network. Yeah, so the entire preset got applied just fine, at which point we can run stuff on it, and that should land on ZFS. And it did. There we go. So that's looking pretty good. Like there's one kind of piece missing, which is actually a missing piece on the Incus side, which is a pre-seed file currently cannot pre-seed certificates. If it did, then we could actually use this to make an actual IncusOS image that you can run on an actual machine. that can now boot, configure network, come online, apply updates, and precede Incus, including trusting your client certificate. And then from your machine, like from your laptop, desktop, you could connect to that server. And even though the server is completely locked down, you don't have a shell, you've got nothing on it, you'll be able to drive Incus. So we're getting very close to having something that can have all of those pieces in place. There's quite a bit more, obviously, as we said, we're currently working on doing installation. So being able to copy from that boot media over to the real disk. Having some amount of disk output, because if you run that on an actual machine, it would be nice if it could tell you its IP address. So we're gonna be doing that. And then yeah, the certificate piece should fall into place on the Incus side soon enough that this will be in place. At which point the main focus is gonna be on API, so that when you run, like when you're on your laptop or on your desktop and you interact with that remote Incus system, you will have access to special commands to actually look at the IncusOS side of things, to check updates, to tweak the network config, to do those kind of things. Because again, there's no SSH, there's no straight up shell, and the entire system is read-only anyways, so it's not like it would help you even if you could. So we're gonna have APIs exposed through the Incus API itself to drive the IncusOS piece that way. All right, so that's basically where we're at. I'm just looking at the chat. There was a question related to Ceph earlier. Is there a plan to integrate it with Ceph Manager, like a replacement for Ceph ADM for Incus? So I think I touched on that before for how we want to handle both Ceph and Oven on IncusOS. The short story is the client pieces will be part of IncusOS itself. So IncusOS will include Open vSwitch, and it will include the Oven controller piece, which is what's used to connect to the Oven control plane and then apply rules locally. For Ceph, that means we're going to have the Ceph client tools. So the Ceph command and the RBD command are going to be part, most likely, of the Incus image, the Incus application. But we won't be including things like Ceph OSD, Ceph Manager, Ceph MDS, and all of those Monitor, and all of those services directly in the IncusOS image. That would make it way too big. And that's also not flexible enough, because you need some ability with Ceph to do progress, and with Oven too, to do kind of incremental updates on those services separate from the OS itself. So the plan is to run those kind of things. So the Oven control plane and the Ceph control plane and even the Ceph OSDs, run those as containers. So running them as OCI containers on top of Incus that's running within IncusOS. By doing that, we'll have the ability, at least for the main control plane pieces, like the Ceph monitors and the Oven databases, they will be able to move around within a cluster. So you'll be able to have a cluster of 50 completely identical servers running IncusOS. And then you don't have special cases of some of those servers running control plane for Ceph or running control plane for Oven. Instead, that control plane runs within a internal project within Incus. And that means that can get spread over the cluster. If a machine goes down, we can start it back up somewhere else. You get all of the HA benefits for that. And that will also make it easier to manage and update and handle in general. So that's the idea. There are a few pieces missing on the Incus side to make that work seamlessly. Mostly we need another networking piece that can give us just a basic mesh network effectively, so that we can have an instance that is not running on Oven, that will have the same IP address regardless on what machine it runs within the cluster. And yeah, effectively have that work without any external dependency, because we need that to then run the control plane for Oven to then provide the rest of the networks. It sounds like there's a chicken and egg problem, right? Like we're putting control plane on top of Incus, but then Incus accesses the thing. That's something Incus supports already. Basically, Incus understands that some networks and some storage pools may not be available right on first boot, and it will still start whatever else it can. So it's gonna start that internal project. All of that stuff will be running on local storage, will be running on local networks, so that can start up immediately with the cluster. And then anything that runs on Oven and runs on Ceph will be effectively on hold until those control plane instances are up and running, at which point the Incus servers notice that it's available and then pick things back up from that point on. So yeah, that's basically how we're looking at handling that stuff. And it's not only for large scale deployments, like I mentioned, a cluster of 50, but that's also the plan for kind of smaller home laptop environments where the goal is very much that you should be able to install IncusOS on the server, basically point a web browser at the UI or use the Incus CLI to add it as a remote. And then once you're in, you can draw that cluster to have more machines in it. Once you have an actual cluster, then you've got a command to effectively deploy the OCI containers for something like Ceph or Oven if you want that in place. And then once you do, you can, like IncusOS can pick that up and reconfigure Incus itself to use it. So that's the idea, to try to kind of tighten all that stuff, pull it all together. I think the goal of the internal project with OCI containers running services is can go quite a bit further. It can also include Grafana, Prometheus, Loki for all of the observability stuff. It can also include Keycloak and OpenFGA for authentication and authorization. It can include like a reverse proxy. It can include all of those kind of things. So I think there's going to be a bit of like flexibility there, like room to grow, to put a bunch of those standard kind of cluster services effectively getting automatically deployed and automatically run and get updated within that project. So you don't really need to think much about it. Like you'll still see them, you'll still be able to interact with them directly, but by and large, IncusOS will be in charge of deploying them and keeping them fresh. So you don't really need to think about it. And you get to just use a fully featured cluster without having had to spend days or weeks like learning about all of the different components, how to configure them, and putting everything together yourself. So yeah, I think that's where I'm gonna leave it. I'm not pushing a pull request just yet because I don't really like that it's all kind of hard-coded all over the place as for the Incus preceding. I want to take a stab at having like basically an interface around the applications and being able to say, okay, well, this application is Incus. If the Incus application supports initial configurations, it's got a function for that. It supports some other features, and then we do that, like instead of hard coding, oh, okay, this is Incus, so I need to run this stuff on startup. It's just gonna be, I've got 5 applications, let me go through them, and then if they have a startup function, call that. If they've got a initial configuration function, and it's the first time I'm running them, run that. If there's like an upgrade function, I'm just applied an update, run that. So that's kind of the idea. I just want to put that rough structure in place so that there's not so much hard-coded Incus logic within the startup sequence. And yeah, hopefully I get to do that later today or tomorrow, and by the time we look at things. So next week, there's not going to be a live stream because it's an Incus release week. So with an Incus release week, it's going to be an Incus release video coming up on Friday, which means the next live stream will be the week afterwards, where I'll probably provide a lengthy-ish update on IncusOS, because by that time, we should have installation, we should have some other, maybe even the console handling, and some of those pieces will most likely have landed already by then. All right. Thanks a lot for watching. Thanks a lot for the questions. If anyone's watching this after the live stream and has questions, feel free to leave them down below. You can also go on the community forum and just stay tuned. Like, there's a lot of interesting stuff. There was that migration manager video that got published last week to show that aspect of things, where the team at Future Fusion is also actively working on Operations Center that we hope to have go public on GitHub in the coming weeks. And there's just a lot more stuff going on. Like, we've had a lot of pull requests from community members on the Incus side, lots of very exciting work there. The Linstore storage backend should be ready to merge. I just need to find a time to review it. I'm currently working on landing another pull request for network address sets. We've got some new USB storage and USB network support for VMs coming in too. There's really gonna be a lot. I think this this Incus release, the previous two I found were a bit lighter, which makes sense. January is right after the holidays, pretty light. February, I usually travel to FOSDEM and other conferences, which takes close to half of the month because February is a shorter month. Um, so not too much happened on the February release either. I think the March release is going to be quite a busy one. And by the looks of it, the April and May releases are going to be just as busy. We're also making good progress on the Terraform provider. So we've got the 1.0 milestone that's been open for a while. All of the main features are in now. I think there's just a few more tweaks and renames and things that we want to tidy up, but we're very, very close to doing a 1.0 for the Terraform provider, at which point we're going to try our hardest not to break backward compatibility again. That's the main reason for wanting a 1.0 was that I wanted to rename a bunch of things. I wanted to change some concepts. So we've been doing that pretty aggressively so far, and starting with 1.0, we're going to refrain from doing any of those kind of changes, mostly sticking to bug fixes and like feature additions that don't break backward compatibility. All right. Again, thanks a lot for watching. I'll talk to you in I'll see you and talk to you in the next stream in a couple of weeks. Bye, everyone.